We start out with some factoring once again, but this time we're factoring in order to solve an equation. So the key thing to remember is that it has to equal 0 on one side, which it already does here. And then we only have two terms. And then the first thing you always want to do is look for the GCF. So do you see a GCF in number 1?
Yes.
Yes. What is it?
It would be X.
Good. So if we factor that out, what does that leave us with?
X minus 1.
Good. Then we use that zero product property, which says that if two numbers multiply together to equal 0, one of the numbers has to be 0, because if not, there's no way you're ever going to equal 0. So then that tells us that either X equals 0 or X minus 1 equals 0, which gives us a solution of 1. So our two solutions are 0 and 1. Okay, so what would be the first step for number 2?
So you'd have to set number 2 to 0
Mm-hmm.
By subtracting the 32 from both sides.
Perfect. And then this time, since we have 3 terms, we're going to have to factor. But this is an example where we can do that quick factoring that I was mentioning last time, because it's just an x squared. There's not a coefficient in front. Mm-hmm. So what are two numbers that multiply to negative 32 but add up to negative 4?
That's an 8 and a 4.
Mm-hmm. And then what would the signs be?
Negative 8, positive 4.
Very good. Mm-hmm. That's how it factors. So then what solutions does that give us?
Positive 8 and a negative 4.
Good. Perfect. How about number 3? What do we have to do first in number 3?
With that one, you would still have to set that to 0, right?
Correct. So I know it's tempting. Sometimes people say, well, it's already written like in factored form, so I can just say like, oh, x minus 1 equals 4x and x plus 3 equals 4x, mm-hmm. But that doesn't work. That property only works for 0. It doesn't work for other numbers, because for other numbers, you don't have to use the number itself. So for example, the number 8, if I said, can you give me two numbers that multiply to 8? You could say 2 times 4, right? Mm-hmm. So to equal 8, one of the factors doesn't have to be 8, right? That property only holds true for 0. So the first thing you actually need to do here then is to FOIL this out and then move the 4x over, and then you'll be able to factor, because it'll then equal 0.
Yeah.
Okay, good. So we're going to FOIL first. So what's x times x?
It'd be x squared.
Mm-hmm. And then keep going.
Plus 3x.
Good.
Minus x.
Mm-hmm.
Minus 3.
Mm-hmm. And then that all equals 4x on the other side. Running into the last problem a little bit. Okay, so then we want to combine like terms. So 3x minus x is going to give us 2x. And then we can move that 4x over to the other side, right? Because we want to have it equal to 0. So I'll go over here. So now I have x squared minus 2x minus 3 equals 0.
And then you'd have to factor that out, right?
Exactly. So how would that factor?
You would do a 3 and a 1.
Mm-hmm.
So it'd be a negative 3, positive 1.
Very good.
And then you would get x is a positive 3 and x is a negative 1.
Very good. So what would you do for number 4?
So I'd get rid of the parentheses. So distribute the x.
Mm-hmm. Which gives us?
9x squared minus 2x. And then set it to 0. So subtract the 11 from both sides.
Very good.
I guess you'd factor that out, right? So
what factoring method do you want to use?
The trial and error.
Mm-hmm. I thought you were going to say that because I know that's your preferred method. I remember that from last time.
Yeah.
Okay, so let's try. Hopefully we don't err, but that's okay if we do, because that's how the method works, right?
Mm-hmm.
Try, it doesn't work, you try again, and eventually it works. Okay, so what do you want to try?
I'm just going to go with the 9x.
Okay, so 9x and x. Okay.
But 11 is prime, right? So, so nothing is really going to factor this out.
Well, what numbers multiply to 11?
Nothing. It's just 11 times 1.
Yeah. So you can use that.
Okay.
So let's put an 11 and a 1.
Be like, oh, okay. Never mind. I see it. If you did
And
it
then
that
how
way.
do you want to try the signs?
All right. So it'd be a negative 11 and a positive 1.
Good, because if you FOIL that out, which you can do off to the side, I'll do it right above it, you get 9x squared plus 9x minus 11x minus 11, which does combine back to the original problem. Very good.
All right.
So then we use the zero product property one more time. So what solutions does it give us this time?
So you get a negative 11 over 9 and you get a negative 1.
Okay, I agree with you about the negative 1, but it should be positive 11 over 9 because you had to add 11 to each side.
Yes, I see that now. Sorry.
Oh, you're fine. Good. Okay, for number 5, what would you do first there?
I would pull out the GCF.
Which is?
And X.
Good. That leaves us with x squared minus 10x plus 21 inside parentheses. So then how would that factor?
That would be an X minus 7 and an X minus 3. So you would get an X equals 0, an X equals a positive 7, and an X equals a positive 3.
Very, very good. Before you even worked out the problem, what would be a hint that this problem might have 3 solutions? All the other problems we had done so far today had 2 solutions, right? But what would be a hint that this one might have 3?
Because you have 3 variables.
What do you mean by that?
You have the X that you pulled out of it.
Yes, you have the X that you pulled out of it. So then the hint would be that the original polynomial had this X cubed, right? That the biggest exponent was actually a cubed. Whereas in the other problems, it was always just a squared, right? If you go back and look at them, it was always just squared. So that's a hint that you may have more solutions. Now, you don't always know. Sometimes there's a duplicate solution, but there should be 3 solutions there. Some of them could be imaginary, but there should be 3.